derivative is just a fancy way of finding out how fast something's changing at one exact moment. To find it, we can use two main shortcuts. The first one is the power rule. We'll get 4x to the power of 3 plus 5x minus 1. You just bring the exponent down and multiply the front number, then drop the power by 1. In this case, 4x to the power of 3 becomes 12x squared, 5x just becomes 5, and the constant negative 1 just vanishes, so you get 12x squared plus 5. The chain rule is for when the stuff is inside of the parentheses. In this case, parentheses 3x squared plus 1 parentheses to the power of 5. So for the first step, we do the outside first. We bring the 5 to the front and drop the power to 4, and we leave the inside alone for now. That's 5 parentheses 3x to the power of 2 plus 1 parentheses to the power of 4. Then we multiply by the derivative of the inside, which is 6x. We can finish by cleaning it up. 5 plus 5 times 6x gives you the final answer of 30x parentheses 3x to the power of 2 plus 1 parentheses to the power of 4. Now we can go to the next slide. If you can remember clearly on what the power rule is, we can do 6x to the power of 3 minus 9x plus 4, which is really just f prime of x is equal to 18x to the power of 2 minus 9. The little tick mark here means derivative. Next, we can do y is equal to 2t to the power of 4 minus 10t to the power of 2 plus 13t. If you want to take a moment to pause the video and try this problem by yourself, you should do it. Now that you've had the time to think about it, the next problem, we're using t instead of x. We can write the derivatives as dy over dt, which literally just means change in output over the change in input. The math just gives us 8t to the power of 3 minus 20t plus 13. Over on the right, now that you've done two derivative questions, you should be pretty confident in doing this one. Now, hold up. You might overthink this one though, but it's actually not too bad. Because if you look at the equation, we can just simplify it to y is equal to x to the power of a half plus 8x to the power of 1/3 minus 2x to the power of 1/4. This also gives us dy over dx is equal to a half x to the power of negative a half plus 8 over 3x to the power of negative 2 over 3 minus a half x to the power of negative 3 over 4, but the 4 is cut off. My bad. The next thing we're going to do is a word problem. Yeah, I hate word problems, but this one is probably not too bad. This is where math can sometimes go in real life. In this problem, it asks us how fast the ball is moving after 2 seconds if the ball is thrown straight up. Its height in meters after t seconds is ht is equal to negative 5t to the power of 2 plus 20t plus 1. We can start off by doing the derivative of negative 5t to the power of 2 is equal to 10t. The derivative of 20t is equal to 20, and the derivative of 1 equals 0, so we leave that out. After we do that, this will give us h prime of t is equal to negative 10t plus 20. The last step is to plug in t equals 2, which in this case it's h prime of 2 is equal to negative 10 times 2 plus 20 is equal to negative 20 plus 20, which is equal to 0. The final answer is, well, 0 meters per second. But the meaning of this question is at 2 seconds the ball is momentarily not moving up or down at its peak. Anyways, thanks for watching.